The next volume formula that you need to be aware of is volume equals 1/3 of B times H. Okay, 1/3 the area of the base times the height of the solid. This works for both pyramids and cones. Okay, the capital B and the capital H still represent the exact same thing. Okay, so if you were looking at a pyramid with a rectangular base and a given height, H, when you're finding the volume formula for this, once again I would suggest that you begin with the general equation for the formula, followed by the specific equation. So what would the area formula be for this base shape, assuming it's a rectangle, base times height, and then all times capital H? Here would be the appropriate volume formula for this figure, or this shape. Again, if you have, let's say, a regular pentagon as your base, the volume formula is 1/3 BH, where B represents a regular polygon, 1/2 SAN, all times H. So once again, you're going to have any number of formulas for this. It's all based on whatever shape the base is. The cone works the same way. You have the single base connected to a vertex. You have the height of that cone and the radius of the base. So the volume formula is 1/3 capital B, capital H. Well, in a cone, just like a cylinder, the base is always a circle. So the area formula for that base shape, capital B, is pi r squared. H is the height of that solid. So for a cone, you'll always have this formula, but once again, you don't really need to memorize it separately because you should be able to derive it from what you already know of circles. Okay. All right, I want you to see if you can find the total volume of this trapezoidal pyramid. Okay. Can you find the volume of this figure, of this solid? The base angles, the base is an isosceles trapezoid with base angles of 45 degrees. You start with what you know, our volume formula, 1/3 capital B, capital H, and be followed by the specific equation. The base shape is a trapezoid, so what is the area formula for a trapezoid? 1/2 sum of the bases times the height of that trapezoid, and that's all going to be multiplied by H, the height of the solid. And so let's plug in what we know. Now, if you're writing these out, I'd suggest that you leave any fractions written without combining them. I'll explain this in just a second, but just say leave the 1/3 times 1/2 base 1. So here's base 1 is 4. Plus, how can we find base 2? Josh. Good. Okay, and so what's this portion here? So this portion is opposite rectangle, so a length of 4. And then when you create these 45, 45, 90 triangles here, what is this portion going to be? You have 3 root 2 as the hypotenuse, therefore each of the legs is 3. Same holds true over here. So when you look at this whole base 2 is 4 plus 3 plus 3, so it's a length of 10. And then the height of the trapezoid itself was 3. And then the height of the entire solid is 10. So you can then fill in all the values for this. Now here's the reason why, if you're solving these by hand especially, instead of combining these fractions into a 1/6 and then trying to cancel factors, oftentimes the canceling can be done even more simply if you leave them as individual factors. So this factor of 3 cancels directly with this 3. 4 plus 10 is 14, and half of 14 is 7. 7 times 10 gives you your final answer of 70. The units are unknown. It's a volume, so it's a three-dimensional measure. So your answer would be 70 cubic units. Okay. Questions for these, the pyramid and cone. 1/3 capital B, capital H, where B is the area of the base, H is the height of the solid. Okay, the final formula that you need to be aware of is volume equals 4/3 pi r cubed. This is the volume formula for a sphere. Again, the only dimension is a radius, but since it's a volume, it's a three-dimensional measurement, you'll cube that radius. Okay. So the only variation off of this that you might see would be if you had half of a sphere or a hemisphere. The volume for the hemisphere would simply be the fraction of 1/2 of whatever the volume for the sphere would have been, 4/3 pi r cubed. So again, you don't need to memorize a separate equation for this. The 2 does simplify with the 4, creating a simplified equation of 2/3 pi r cubed. So the volume formula for a hemisphere does have a specific equation, but you don't have to memorize it. If you just think about it being half the sphere, you can solve it with only, again, memorizing those 3 volume formulas. Capital B, capital H for prisms and cylinders, 1/3 capital B, capital H for pyramids and cones, and then 4/3 pi r cubed for a sphere.